So in this example, the airline company would be interested in the probability that more than 20 ticket holders come to the airport, right? So like that is the probability of any trouble. And mathematically, we are looking at the probability of y, the number of non-cancelled reservations is greater than the capacity of that flight, right? Y greater than 20. Then so earlier we derived the probability for y, but the form of the probability was probability y equals to lowercase y. But now we need inequality. How can you calculate this probability? The answer is there is no easy way. There is no shortcut. You have to replace this inequality with multiple equalities. So like this. So we are interested in probability y greater than 20, and greater than 20 includes only two possible cases. When there are 22 passengers, which is the maximum possible, and there are 21 passengers. In these two cases, you are in trouble. The company is in trouble. So calculate that probability. You know how to calculate this probability using the formula we derived. And also you know how to calculate this probability using the formula we derived. So the formula gives you these two guys. So again, the first part is the number of possible combinations according to the combination rule. And the second part is the probability of a single outcome. So here, 0.9, it is non-cancellation. Probability of success happened 22 times because we are looking at this probability. So all 22 tickets are not canceled. 90% realizes for 22 reservations. And the other side, 0. No one canceled. Probability of cancellation does not realize. And in the second case, you are choosing 21 out of 22. So among 22 reservations, 21 are not canceled. And what is the number of possible combinations? And multiplied by probability of a single outcome. Probability of non-cancellation happens 21 times, and cancellation happens only once. So we get this probability, and if you calculate them, you get this in the end, about 34%. Nearly 34% is the probability of overbooking, overbooking causes of trouble. This is what we get. And I forgot to use the colors. So this is how we get the answer. And then I'm asking you this: what if the airline decreases the reservation limit down to 21? So previously, they sold 22 tickets, even if there are 20 seats, but they realized that, selling 22 tickets is dangerous. So the probability of potential problem is too high. So let's reduce the scale of overbooking. So they are selling only 21 reservations. What is the probability of the problem? Try to answer this question. It may take a little more time. You may use Excel or calculator, and you can go back the previous slides to see what formula you need, and try to answer this question. Pause the video. I'm going to give you the answer. 1, 2, 3. The answer is 10.9%. So the answer is C. Now, so in this case, it is actually very easy because there is only one possible outcome that satisfies this inequality. So more than when you sell 21 reservations, that means you are in trouble only when 21 all of the ticket holders come to the airport. So that's the only case, and the probability can be obtained using the same formula as before. So you consider only one, y equals 21. There is no other possible y. And what's interesting here is another counterintuitive thing here is, so when you reduce the number of overbooking from 2 to 1, in some sense it's like reducing the overbooked tickets into half. But the probability is reduced from nearly 44% to 11%. So probability changes a lot. So this is another counterintuitive aspect, behavior of binomial distribution. So it is very counterintuitive. Like so if you guess, so you may think, and here probability is about 34%, and you are reducing it down to 21. So the probability would be the same or like halved. No, those two numbers have no relationship to each other. So they are calculated based from the same formula, but from different parameters. So the relationship between them is murky. So it's not that simple. And here I am going to show you how to calculate those probabilities in on Excel. So suppose that I'm going to show you this. You sold 22 tickets, but there are only 20 seats. So this is our setup. Then what is y? Y is the number of ticket holders who want to take the flight. This is exactly what we considered. And then what is the probability of y greater than 20? I am going to calculate this probability. First, probability y greater than 20 cannot be calculated directly. What I'm going to use here is, I will use less than or equal to 20. So we are interested in probability strictly greater than 20, but this is not convenient. But we would like to transform that probability into this form. So greater than 20 is the complement of y smaller than or equal to 20. So using the complement rule, you can calculate the probability as 100% minus the probability smaller than equal to 20. And then probability smaller than or equal to 20 is less than or equal to 20 is a cumulative probability. Do you remember the definition of cumulative probability? This is the definition. So if a probability is defined as smaller than or equal to something, then that is a cumulative probability. We learned cumulative probabilities in chapter 3. So remind yourself. And then this cumulative probability, there was a cumulative probability option for binomial distribution. So choose binomial distribution formula. And then in this case, we are interested in number of success, number of non-cancellations, 20 or smaller. and there are 22 trials. Out of 20 reservations, we are interested in 20 or smaller, and probability of success is 90%. So we found those two parameters in a previous question, and we are interested in 20 or less. And now you change this entry to true. So we are interested in a cumulative probability. Then you have to put true here. So put true. That is this much. And then the original, so we are just calculating this probability. We are calculating this red part, but the real probability we are interested in is 1 minus this guy, the cumulative probability, which is about 33.920%. This is what we obtained in our slide. Excuse me, right? So we obtained the same probability. So what I'm showing you here is, in principle, the cumulative probability defined by an inequality should be split into multiple probabilities of equalities. However, you can do it simply on Excel. Excel will do the work, do the algebra for you. But what you have to be careful is you have to understand what is a cumulative probability. You have to so you can calculate a cumulative probability and then transform the cumulative probability into what you want. So it requires an additional step. So if you want to use Excel for your homework, and then this will be super useful. So try this. Okay, I'm going to, so I have a few more slides with another example. So I will show you. So let's do it here. I'll do it in the next video. Sorry about that. So see you in the next one.